Okay, so we're going to go ahead and look at solving equations. Now, when we are solving, we are still thinking about undoing our operations. So we've got the add and subtract. We've got the multiply and the divide. And we've got exponents. Now, there's a couple types of exponents. We have looked at how powers and roots are inverses of each other, or they undo each other. And as we saw in our 8.5 section, logs and exponentials are inverses of each other. So when we get to this E step of our solving, we are going to be using logging and exponentiating to assist us with our solving. Okay, so we actually have 4 types of problems that we are going to solve. And we're just going to do it by example. So here we go. Type 1. 1 exponential. You have one exponential. Okay, and so we're going to 1 exponential, 1 variable. Means we've only got a single x that we are trying to solve for. Let's look at what a potential example could look like. All right, 1 exponential b to the x equals, let's pick a letter, w, right? Just a number. You have 1 exponential, and then it's equal to some expression or number. How do I solve for x? We learned about logging both sides. So I'm going to take the log base b of both sides and, right, of everything that's on that side. Using that inverse property, we will end up with x all by itself, log base b of w. All right, look at that. If you have an exponential equation, you can solve for x by logging both sides of the equation. Here we go. Solve for x. Okay, so let's start with, I'm going to write my numbers double tall so that we can see where the exponents are. Okay, and I'm just going to underline my exponent. All right, so I have a single exponential, a single x, and I would like to solve for x. So I'm going to start by taking log base 5 on both sides of the equation. Okay, notice how I write the log base 5 and then I just fill in with what was on the paper, equals, here's the other side, and I simplify using that inverse property. We get x plus 2 on the left and log base 5 of 10 on the right. And then I continue to solve for x. And believe it or not, that is your answer. Did you get x by itself? Yes. Okay. Now, I don't know what log base 5 of 10 is equal to, except that it's between 1 and 2, and it's probably closer to 1 because 10 is closer to 5 than 25. But that is the answer. That's it. Check. Okay. You could get an approximate by using your calculator or Desmos. Okay. So let's look at question number 2. All right. Let's say we have 3 to the x plus 1 equals, notice I'm making my numbers double sized so that we can see the exponent, equals 8. Okay, solve for x. Keep in mind your PEMDAS. Before you get to the e, you have to undo the add, subtract, multiply, divide pieces. So I get 7. Now I can take the log of both sides. Okay. Log base 3. Okay, I'm choosing base 3 because I want the side with the x to simplify nicely with my inverse property. X equals log base 3 of 7. That is the answer. That's it. Okay, let's go ahead and maybe do 2 more examples here. Okay, I'm going to add a couple more operations to our examples. Example number 3. All right, so say 2 times e to the x minus 3 plus 4 equals 6. All right, so I've got a 2, a minus 3, and a plus 4. I'm going to underline the exponent because that comes in the e step. So I've got to think about my PEMDAS, right? The red part, that's the e part. So you better take care of the 4 and the 2 first. Okay, so add, subtract. I'm going to minus the 4. Okay, then I'm going to divide by 2. Okay, now I'm to the e step. Now that's a, right, e, so I'm going to do natural log of both sides. Okay, natural log of both sides. My inverse property tells me that this part cancels and I'm left with x minus 3. Now, natural log of 1 is 0. I just happened to be able to evaluate that to a number, so I did. And then I continue solving for x. Whew. All right, let's do another example where we have a couple more operations here. 4 times 1/2 3x minus 1 equals 5. Whew. Okay, solve for x. So I'm still thinking about my PEMDAS. Okay, and let's see, I don't have any add or subtract, but I do have this divide. So I'm going to start by dividing by 4 on both sides. Okay. Okay, and then I've reached the exponential portion. Okay, so I'm going to take log base 1/2 on both sides. Log base 1/2 on both sides of the equation from whatever is here. Okay. And simplify. I know that my inverse property tells me those two things cancel out, and I'm left with 3x minus 1. Now on the other side, just log base 1/2 of 5/4. Okay, I don't think that simplifies because 5/4 is not a power of 1/2. And then I solve for x. So I'm going to add 1. To both sides. Okay. And then I'm going to divide by 3. Okay, dividing by 3. Look at that. Okay, that's 1/3 log base 1/2 of 5/4 plus 1/3. Okay, good luck. Go ahead and try the first set of solving questions.